Hi, welcome back to Missing Chemistry. This is Molecular and Empirical Formula lesson number 14. Alright, let's look at the problem. A compound has a molar mass of 86 grams per mole and a percent of composition made up of 55.8% carbon, 37.2% oxygen, and 7.0% hydrogen. From this information, write the empirical formula and the molecular formula. Hint, remember that 1% is equal to 1 gram. That's very, very important, okay? All right, so let's go ahead and do this. So if we have 55.8% carbon, that means we have 55.8 grams of carbon. So we have 55.8 grams of carbon. Okay, so if we have 37.2% oxygen, that means we have 37.2 grams of oxygen. And if we have 7.0% of hydrogen, then we have 7.0 grams of hydrogen. Now what we're going to do is we're going to have to change this into moles. So we have to look at how many grams per mole each of these elements have. So we look on the periodic table, and carbon has 12.01 grams per mole. Oxygen, on the other hand, it says 15.99 grams per mole, but to make it simple, we'll just call it 16.00 grams per mole. And then last but not least, hydrogen has 1.01 grams per mole. All right, now given that, what we're going to do is we find out that when we divide 55.8 by 12.01, that gives me 4.65 moles. Okay? Because our grams will cancel out. We divide 37.2 by 16, we get approximately 2.33 moles. Okay, so our grams will cancel out again. When we divide 7.0 by 1.01, we get 6.93 moles. All right. So everything's working out pretty good. Now what we're going to do is we're going to divide each one of these moles by the smallest number of moles that we have represented here, which is 2.33. So we're going to divide this by 2.33 mole. We're going to divide this by 2.33 mole. We're going to divide this by 2.33 mole. And when we do that, okay, this is going to give me 1.99, which we're going to call 2. This is going to give me 1. And remember, our moles have canceled out, right? So all that's canceled there. And 6.93 divided by 2.33 is 2.97, which we're going to call approximately 3 anyway. So now our empirical formula is going to be C2OH3. Now that's our empirical formula. So now let's figure out what the molecular formula is. So we have to remember that the molecular formula is 86 grams per mole. So that means we're going to have to find the molar mass of C2OH3. So we're going to have to erase all this so we can give ourselves some room. So let's go ahead and do that. This is a lot of fun stuff. You could actually do this with your friends. Yeah, go out with your friends, you know. Hey, let's figure out empirical molecular formulas. You'll definitely be the hit of the show, I will tell you that. All right. Okay, here we go. Let's finish erasing here. All right. So now we got to rewrite this formula. Let's get the writing going again. Here we go. C2OH3. So now that means we're going to have to erase one more thing here, guys. Clear up our board. Right, now we have to figure out the grams per mole of the compound C2OH3. Now to do that, we're going to go carbon is 2 times 12.01, it's grams per mole. And remember, we're getting that from the periodic table. Oxygen, we got one of those, so that's going to be 1 times 16.00 grams per mole. And of course, we have 3 hydrogens. It's going to be 3 times 1.01 grams per mole. All right, so let's add all this up. This is going to be 24.02. This is going to be, of course, 16.00. And this is going to be 3.03, and these are all grams per mole, of course. Now we're going to take our calculator, we're going to add all this up, so give me a moment. 24.02 plus 16.00 plus 3.03. That's going to give me approximately 43.05 grams per mole. Yeah, there's some flickering still going on in these new videos. We're still working the problem on our end, so just kind of ignore it. All right, now we're going to take and divide that into 86 grams per mole. So we go 86 grams per mole divided by 43.05 grams per mole. And of course, these units are going to cancel out when we do division. So let's go ahead and divide that. 86 divided by 43.05. And that's going to give me approximately, that's going to equal exactly 1.99, which we're going to approximately call 2 because it's close enough to round off to 2. So we're going to take this 2 here and we're going to multiply each of these numbers by 2. So this is going to be C2 times 2, O1 times 2, and H3 times 2. Our molecular formula is going to be C4O2H6. And that's it, guys. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Machine Chemistry.